And let's go ahead and start talking about Terraform on Oracle Cloud Infrastructure. This is aimed specifically for database administrators. So let me just get into the right application here. There we go. Okay, so my name is Sean Scott. I've been working with Oracle technology for about 25, 26 years now. I try not to keep track quite so much because it makes me feel old. I've been presenting and working with user groups for almost that long, and I've spoken at Oracle Open World and the Collaborate IOUG conference, the Oracle Application User Group Conference in my early days when I worked with application databases, spoken with some groups here in the US as well as internationally. I work for Viscosity North America. We're an Oracle Platinum partner. And most of the work that I do with Viscosity centers around upgrades and migration. I do a lot of work with high availability systems and disaster recovery. A lot of work with real application clusters, data guard, engineered systems, and so forth. A few years ago, started working with sharding, and I do a lot of work with the observability platforms. So Trace File Analyzer, Autonomous Health Framework, Cluster Health Advisor, Gimmer, so on and so forth. I have a really strong background. I spent a number of years working in an operations environment. So I've got a lot of experience in the DevOps space. I do a lot of automation, work a lot with infrastructure as code, data as code, work extensively with containers and Docker. Some of you may know me by reputation as the Docker DBA, do some work with virtualization. Currently in the process of finishing up a book on Oracle on Docker or Oracle on Linux containers. Hopefully, we'll see that published with A-Press later this year, if I can finish off those last few chapters and make my editor happy and get everything done in time. I am an Oracle ACE and also an Oracle Certified Professional. And let's go ahead and start talking about Terraform. So when I was a kid, I read a lot of science fiction. And I remember there were a number of books and stories that reference terraforming. And that term seems to originate somewhere around in the 1940s. And it was meant to refer to taking an alien planet and making it habitable for human life. Oh, here, let me, I'll go ahead and start my video for you here so you can see me waving my arms. I speak a lot with my hands, so I apologize in advance for that. And please, if you have any questions, if you have any comments, anything of that nature, feel free to drop them into the chat. It doesn't bother me. I have a chat window open here, so if you drop something in there, I'll see it and I'll answer your question for you as soon as I have an opportunity. So we were talking about Terraform and how this originated in science fiction, started out around in the 40s, and it talks about taking an alien planet and making it habitable for human life. And we even see this now in current science fiction. I remember seeing in the Superman movie Man of Steel, terraforming is part of the plot line. The villains come in and they attempt to transform Earth to make it more like Krypton. So we see this terraforming term in popular culture. It's part of Animal Crossing game. There's terraforming that takes place. But this whole concept of terraforming isn't really limited to science fiction, and it doesn't even require an alien planet or even modern technology, because human beings, we have been terraforming the planet for thousands of years. And this includes things like rice fields, creating vineyards. We have whole cities like Venice that were created in a lagoon, greenhouses, and even aquariums. So if you've ever owned a fish, a reptile, kept an herb garden, raised tomatoes or orchids or tulips or any other type of plant outside their native habitat, you have done some terraforming of your own, which means that we're all coming into this with a little bit of experience, whether you realize it or not, to today's subject, which is Terraform the noun. So Terraform is an infrastructure as code tool from a company called HashiCorp. And these are the same folks that brought us Vagrant and Packer. And Terraform is a tool for defining infrastructure through configuration files. And those files tell Terraform what we want the end result to look like. And then Terraform does the work for us. It builds out infrastructure to match our specifications. But Terraform goes beyond just simply provisioning infrastructure. Again, these configurations that we create for Terraform, they declare an end result of what it is that we want. And so Terraform takes care of those details for us. But beyond being just an infrastructure provider, those configurations, those end results that we want to have, they let us revert environments to a known controlled state. So if something gets out of sync, we can use Terraform to bring it back into the desired configuration, or we can update a configuration and apply changes to that existing configuration in order to extend an existing system. So we can use Terraform to build virtually anything in infrastructure, everything from low-level components like storage and compute and network resources through all of the finishing details of an environment, DNS, security lists, configurations, and even databases, which is what we're going to talk about today. So Terraform as a language, it's considered a declarative language and not an imperative language. And to really appreciate how, at least I think that declarative languages are really nice. So to appreciate the declarative syntax, I want you to think of the imperative steps of putting together a tropical fish tank. So the imperative steps would be, you need to go out and you need to get a tank, but we need to say exactly what size and brand of tank that we want. So that's the imperative. You've got to buy this tank. And then we select a pump that works with that fish tank and a heater that works with that fish tank, and put everything all together according to some very specific directions. And then we're going to add water and we're going to add salt so that we have the right salinity levels. We're going to set the temperature. And at that point, we'll have an environment that we can put fish into, and the fish are going to be happy. But the problem with this imperative syntax, or this imperative way of doing things, is the steps that we take to put together a 10-liter fish tank are going to be different than if we want a 3-liter fish tank or a 20-liter fish tank instead. Not only do we need to have a different tank, we'll need to select a pump and a heater that's going to be appropriate for that tank. Not just to fit the tank, but to support the volume of water. And how does it change if I want a tall, skinny tank versus a wide tank? And when it comes to adding salt, are the ratios fixed, or do I need to adjust things, adjust the salinity based on the volume or the tank dimensions? I don't know. I'm not an expert at fish tanks. I had one when I was a kid, but I don't really know much about it. Well, the cool thing about declarative languages is, with a declarative syntax, all I have to do is say, I want a thing, and this is what it should look like. And I want you to figure out how to do it for me. And if you think about it, that's how most of the things in the world outside of IT work. If I go and I buy a car, I don't go to the dealership and micromanage them and tell them, this is how you should assemble the engine for me. All I do is I declare that I want a car, and I leave the car building up to the people who are experts at cars. So for our fish tank example, I'm doing the same thing. I'll just declare, I want a fish tank and I want it to be this big. And I trust my expert is going to go and they're going to solve all of the problems and all of those little details, like what kind of pump do I need? What kind of heater do I need? How much water do I need? And the salt and everything. And that expert is going to take care of that for me, handle all the process of putting it together, everything. And my expert is also going to know if I have some of the parts for my fish tank already. If my heater fails, that expert is going to know, the heater has failed. So I'm not going to rebuild an entire fish tank or an entire environment from scratch. All I'm going to do is just replace the heater with something that's appropriate for the configuration. But maybe what's the most important thing about Terraform and declarative languages and declarative syntax in general is, by definition, they scale. I'm giving it a scale. I say I want a fish tank that's this big, and it figures out everything from there. So whether I need a really small fish tank that sits on my bookcase, or I'm a national aquarium that wants a 1,000,000-liter shark exhibit, that expert, that provisioner, is going to handle everything for me accordingly. And in Terraform, that expert that we're talking about, the person or the system that understands how everything works and does the work for us behind the scenes, that in Terraform is called a provider. And a provider has a catalog of all the unique features and capabilities of a particular environment. That provider knows the rules of the environment, and it understands how to put everything together to build a configuration that I'm asking for. Now, providers are target specific. There's a provider for OCI, there's a provider for AWS and Google and Microsoft Azure and so on and so forth. And the provider for OCI isn't going to work on Amazon or any of the others, and vice versa. And that makes sense because the architectures and the product offerings in Amazon, OCI, and so forth, they're very different. For example, I don't have an Aurora database in Oracle Cloud, and I don't have Exadata in AWS. So these providers, they understand the environment, but they also recognize all of the dependencies in configurations. So I don't have to go in and say, this is the order that you do everything in. Terraform understands that. It reads the configuration. It sees everything that I want to build, and it determines the correct sequence for provisioning each component in my environment, handles all of that for me. So I can define things out of order. I can say, I want a database. Oh, and I also want storage. And it knows, yeah, you probably want the storage before I can create the database. Excuse me. So what Terraform does is it moves a lot of the complexity of building infrastructure by abstracting it into the provider, by just kind of tossing it over the fence, as we would say, and letting that provider handle the details for us. If I'm writing scripts or if I'm managing a system by hand, I'm going to need to anticipate and define every possible condition that I might run into. But in Terraform, we tell it we want something. We don't have to worry about the implementation details. Now, I mentioned before that Terraform has some awareness of the current state of my system, and that introduces a handful of interesting capabilities. First, a thing called idempotency. If you're not familiar with idempotency, it's a way of saying I can run something against an environment repeatedly, and it's not going to do anything extra to that environment. So just for example, if I were to create a table in Oracle, if I were to create a table in Oracle and that table doesn't exist, it comes up and it says, hey, I'm going to go ahead and I created this table, table created successfully. But if I try to create that table again, I'm going to get an error. Terraform handles that a little bit differently. Idempotency handles that a little bit differently. Instead of trying to create the table that already exists, it recognizes the table already exists and it doesn't create it again. And the nice thing about this is if you ever have any kind of script that goes in and overwrites directories or anything like that, the whole concept of idempotency is that it's not going to do anything damaging to the system. It's only going to do what it's designed to do, and the end result will always be the same. So we can run that script, we can run Terraform repeatedly without fear of damaging anything. If an asset's already created, if it already exists, it's not going to create it again. But if it is missing, it will create it or recreate it for us. The end state of our configuration, that's all that Terraform is after. And so Terraform also has to recognize the difference between the declared and the current state. so that it can manage that idempotency. So it needs to be able to say, this already exists, so I don't need to create it, or this is created incorrectly and I need to correct it. And so it can identify and report on any kind of configuration drift, meaning that I can tightly manage my environments and prevent them from getting too far out of sync. And of course, this means we always get nice repeatable outcomes from Terraform. I can apply a Terraform configuration to different environments, and I'll produce functionally identical systems. The only difference is the variables that I specify related to scale. So for example, with Terraform, one of the issues that I run into with a lot of database customers that I work with is that they'll have a test environment and they'll have a production environment, but that test environment may not be functionally identical to production. And so things that are tested in that test environment may not work the way that they're intended in production because things aren't the same. Well, Terraform lets us handle that. It lets us create these identical configurations that result in identically or functionally identical environments. So I know that while I may not have as much power and I may not have as much storage in my test environment, it will behave the same way. It may not perform the same way. It may not be as fast, but the behavior will be the same. And so finally, we can update configurations as necessary because Terraform has this awareness of what we have now. And we can reapply those configurations to an environment. We can manage the infrastructure through its entire life cycle from introduction and grow it through a mature system. So let's talk real briefly about how we get Terraform, and we'll go from the concept part of the session into the demonstration and the technical part here. So the first thing that we'll do is we'll go out and we'll download Terraform. As you can see here on the screen, whoops, that was not what I wanted. There we go. So there are a bunch of different options here for downloading Terraform. I'm not going to go through all of that. I'm sure that everyone here is familiar with downloading software and setting up software. But as you can see, there are a variety of different operating systems. Basically, you go out to www.terraform.io/downloads and download the Terraform software that's appropriate for your operating system. So you'll do that. You'll get Terraform involved in your system. You'll also need an Oracle Cloud Infrastructure account. You can do this with a free tier account. All of this works perfectly with the free tier account, even with just the free assets only. So you don't need to have any paid account or anything. In fact, the demos that I'm running here are running on a free tier account. But we do need to do a couple of things to set up our security and to tell Terraform where we're going to connect and what we're going to connect to and give it that authorization to do that. So when you go into your OCI account, you'll go into the identity and security portion of your OCI tenancy, and you're going to click on users. And then from there, you're going to select a user that's going to run your Terraform projects. That's going to own those projects. This is the user that's going to connect to Terraform. And from there, you're going to select or click on this API keys option right here in the resources menu. And then that's going to bring up a dialog box, and you'll click on this add API key. And then from there, you'll just follow the directions in the dialog box. So you'll do this add API key button. In this example, I'm letting OCI generate an API key pair for me. And when I do that, I want to make sure that I'm downloading the private key and downloading the public key onto my system. This private key you're going to store on your system. I'm not going to go through the steps for creating and saving a private key on your system because it's going to differ by operating system. But if you do have questions about this, feel free to reach out to me after the session, and I'll point you to some documentation, some information on that. Once you have this private key and public key created and downloaded, or if you choose to use your own public key or paste a public key that you have, you can do that as well. At that point, you'll have your key, and then you also want to get this fingerprint. Now, this is blocked out on mine, but when you've created this API key, you'll get a fingerprint. You will need that fingerprint value for one of the next steps. Then we need to get some information about your tenancy. This is so that Terraform knows what it's connecting to and how to connect to it. So you go up into the upper right-hand corner of your screen. In fact, let me jump over here and move a couple of things. Here we go. So if you go up here into this upper corner, this is where you have all this tenancy information that I'm talking about right now. You go up there, go into the profile up in the upper top right corner and select tenancy from that menu, and then use the copy link under the tenancy information right there. And that's going to copy your tenancy OSID. This is your Oracle Cloud identifier. So you copy that OSID. We're going to put it someplace for safekeeping. Then we're going to go and do something really similar. We're going to get the user OSID or the user information. Very similar step here. And then you're going to need to get the, excuse me, need to get the region identifier. And then we'll have the private key path. This is the path where you saved your API keys that we just created in that previous step. And the fingerprint, that fingerprint that I mentioned is shown with the API key. And this is all the information that you need in order to log onto your system to get to allow Terraform to connect to your system and access your Oracle Cloud Infrastructure environment. And that's it. That's all that we need from the OCI side. Next, we're going to start a brand new Terraform project. For a Terraform project, we want to have our own separate directory for all of our files, and we're going to create these 5 files. There's a file called providers.tf, variables.tf, and then terraform.tf vars, and then main and outputs.tf. Now, Terraform reads all of these files that have that .tf suffix. It's going to collect all the information it needs from that. When we run Terraform, it's going to build its little manifest and understand how to do everything. But we want to pass some information to Terraform through these files. These are the files that Terraform is going to read. And all of these files are available on this GitHub. Here, github.com/OracleSean/Terraform for Oracle DBAs. And I'll put the slide deck in that same repository shortly after I'm done with the presentation here. I'll upload that to the website as well. So all of these files, all of this information is available for you. You can download it. And the only thing you need to do is just put in your specific information, the key path, the tenancy and user OSID, and your region information, what we just collected in those last couple of slides. So let's talk about these different files that we're doing here. This first one here, providers.tf. In this file, I'm going to give Terraform information about the provider that we're using. And the provider in this case is OCI. We would have a different provider if you wanted to do AWS, Azure, and so forth. And this is the information that we're going to use so that Terraform can connect to our OCI tenancy. And this is what we are sharing with Terraform so that it understands that this is an Oracle Cloud Infrastructure environment that we're working with. So think of this as all of your credential definitions. Excuse me. Now, I want you to notice here, I've got these Terraform variables, and this is a block of Terraform code. So you'll see this in the curly braces, enclosed in the curly braces. And I'm telling Terraform that I'm setting all of these Terraform variables, and then I'm assigning values to it. But you notice that all of these values that I'm assigning begin with var dot. Var dot says that I'm assigning a variable value to a variable. So I'm not actually giving physical or real values here. What I'm telling the provider is you have a property that you need for this OCI, and I'm going to tell you the value that you should use for that. And the value is a variable. And we're going to set those variables in the next file that we work with. And that's this file called variables.tf. Now you notice these are the same variable names that we saw before, but you can see that each line begins with this declaration where I say variable, and then I'm giving a variable name. And then I'm giving these little curly braces, and I'm not putting anything in here. Now, these are all variable definitions. This is where I'm going in and I'm telling Terraform, hey, this is a variable, and I want to declare this variable. If you've written some PL SQL, kind of the same thing where you have that declaration section up at the top of a procedure or a PL SQL anonymous block where we initialize that variable. We need to have that variable existing so that Terraform understands it's a variable. Same thing with PL SQL, where we can't just make up variables on the fly. Now, I could, if I wanted to, put a value right here in these curly braces. I could say, I want it to be equal to this value, but I'm not going to. And there's a reason that I don't want to put values in here. And this has to do with the very next file that we're going to work with. See, these variables, this file, all of these files that end with .tf, all of these files will work on any Oracle Cloud Infrastructure environment. I don't need to change anything in any of these files to create infrastructure on different OCI tenancies that I own. You can use them to create the same infrastructure on OCI tenancies that you own. It's the same set of files. I'm taking the unique values out of all of these .tf files, and I'm going to put them into this file called terraform.tf vars, which stands for Terraform variables. Now, these the lines in this file, you see that we've got the same variable names that we defined in that variables.tf, but this is where I'm going to set the values for the OCID that I collected earlier, for the region identifier, for the user OCID fingerprint, and so forth. So with this one file, I'm taking I'm taking all of those potentially volatile, or all of those values that I might hard code in elsewhere. I'm putting them into one single file, kind of like an environment file, or where I set an environment in a bash system or a Linux system. I'm putting all of that into one file. And now if I need to go to a different system, all I have to do is change the values in this one .tf vars file to be appropriate for my production system, my test system, whatever it may be. And so I could just have some different TF vars files for my different systems, but the same infrastructure configurations, the same project files for Terraform work on everything. So I've got a question here. I believe we can give any name for variables irrespective of the block we defined with curly braces. Yes, that's true. You can call these variables my variable 1, my variable 2. I personally try to give them the same names as the variables that are in the original code block, and I'll show you some more code blocks here in just a few minutes when we get into to actually building an autonomous database. But yes, you can give them any name that you like. You're not restricted on variable naming. But like I said, I like to keep them consistent just so that I'm old and not that bright. So it lets me keep track of everything. But thank you for that question. So by putting all of the hard-coded information that I might have for my environment into this single terraform.tf-vars file, it means that I don't need to change anything elsewhere. All of my changes are confined to just this one file. So with all of that set up, now I can initialize Terraform, and then I can plan Terraform and apply Terraform. And I'm going to show you what these look like here real quickly. Terraform init is just the process where I go in and I say, hey, this is a brand new project. Oh yeah, it says, except for some keywords for sure. Yes, you can't, there are reserved words in Terraform. You can't have a variable that has a space in it that would make it 2 words and so forth. So there are limitations. You can't call it anything that you want, but within reason, within the rules. Thank you for keeping me honest there. So this Terraform init command, it's saying, hey, this is a brand new Terraform project that I'm working with. And I need to just kind of initialize things. I need to set up the environment, make sure that Terraform is working correctly and everything, make sure that all my files are created properly. So I run this Terraform init, and you'll see some messages that come up. I'll run this on a system in just a few minutes, and you can see what it looks like. And then the next thing I'm going to do is Terraform plan. Now, Terraform plan is a command that I run. It's non-destructive, and it reads through all of the files in my project, and it says, hey, everything here works, or there's an error here, and there's something you need to take care of. And so here, when you see I ran Terraform plan, it says, hey, there were no changes. Well, there were no changes because all I did was set some variables, tell it the provider, and give some values to those variables through that tf-vars file that I created. I beg your pardon. My throat is getting really dry here. So because I'm not actually building anything, it's going in here and saying, there are no changes. There's nothing that I need to do here. Everything is good. And from here, since I got success from my Terraform plan, I can do a Terraform apply. Terraform apply is the process where it's actually going to go and do something for me if there's anything to do. But if there's nothing to do, as there's in this case, then it just doesn't do anything. It says, hey, you were successful. So let's take a look at what this looks like in an actual system. This is a directory here that I created, and these are the files that I have here. Is this a good size? Can everyone see that print on here? I can enlarge the text if you need to, if it's too small for anyone. But you can see here, these are all the files that we're working with, and there's nothing here that's any different from anything that is in the lab, with the exception is terraform.tf-vars. That's a file that has my OSID and user information in it. So I'm not going to show you that, but I will show you what my Terraform TF-vars example file is. And so this is kind of what it looks like. So you'll see I have this tenancy OSID and user OSID and so forth. Yeah, I got some stuff down here at the bottom that's for a little bit later. We'll work with that in a little bit. So let's go ahead and do this Terraform init. And you see it's going through and it's initializing things. It's probably going to give me not really an error, but this warning message here about additional provider information from registry. And that's just something weird that it does because OCI, I think it's in the middle of 2 versions, or I may have an older version of Terraform here. But down here it says, hey, everything's good. You can begin working with Terraform. So the next thing I can do, actually I should clear this for you. I can run that init command. I'm sorry, I just ran it, didn't I? Sorry. Let's do plan. And so it gives you all this information here. This is the full list. Oh, well, I have a lot more stuff in my, I have the full version here. So this is what we'll see in just a minute. I beg your pardon. Sorry. if I hadn't had those files there, then you would have seen all of this information here. Terraform apply, there's nothing for us to do here. We'll get to this in just a second. All right, so Terraform apply, we've done that. Now let's create an autonomous database in our Oracle Cloud. And we're going to do this entirely through Terraform. So there are some things that we need to do in order to create an autonomous database in OCI with Terraform. And that is, I need to add some information for Terraform so that it can tell OCI how to build my autonomous database. And I'm going to do that by adding a resource, the resource being my autonomous database, saying I want an autonomous database. And I'm going to put that into a file called main.tf. I'm going to add some variables because, there are some options that I have when it comes to building an autonomous database. So I want to be able to tell Terraform exactly how to build it. And then the values for those variables that I'm going to substitute in, I will put into my terraform.tf-vars file. So those are the hard-coded values, the ones that might change with each environment or each platform that I'm running. And then I'm going to create another file here called outputs.tf. And this outputs.tf is just going to report some information up onto my screen so that as Terraform is running, I can see what it's doing. I can get some feedback from Terraform. So this is my main.tf file. Now, I should say, when it comes to file naming in Terraform, I've created a file called variables, and a file called provider, and a file called outputs, and a file called main. This is my personal coding style, and I'm going to talk about this a little bit later. I do this because it lets me keep all of this information separate. You could, if you wanted, put it all into one big file. And I have some friends, some colleagues that I work with that do it that way. And there's not a right way or a wrong way, but it's not my way. And so it drives me nuts when people do that, because it's like, why would I want this big long file? I like to have little modular files because then I can kind of cut and paste or copy files from one project to another. Maybe that's cheating, I don't know. But let's talk about our autonomous database resource. And this is what is actually in this main.tf file. This is everything, absolutely everything that I need to create an autonomous database. And if you've done this before manually by going into Oracle Cloud and created an Oracle autonomous database, then some of this is going to look familiar to you. Like you'll see, oh, hey, look, you know what? I need to give my database a name, and I need to have a display name, and I need to tell it the version and what kind of workload, whether it's going to be a data warehouse or a transaction processing database, how many CPU cores, how much storage. All of these things are things that are probably familiar to you if you were paying attention when you created an autonomous database in the past, or if you've created an autonomous database, if you've had that opportunity. But what I want to show you is this configuration block and this whole resource creation here. So I'm creating this resource, and the type of resource is an OCI database, autonomous database. There are other types of OCI databases. There's Exadata Cloud, or not Exadata Cloud Customer. There's an Exadata, I forget what the resource name is. You have all these different types of not autonomous, but OCI databases that you can create. So this is just saying it's an autonomous database. That's what I want to create here. So this is the type of resource. And then this very next thing here, this trips up people a lot. This is the name that we're giving to the resource. This is a name that I'm choosing. I'm calling this resource autonomous database. I could call this autonomous database 1. And if I create another one, then I would have autonomous database 2. This is how Terraform is going to recognize which resource or which object, if you will, it's working with within our whole big Terraform configuration. And this gets important when you have multiple similar environment or similar resources. So you might have a bunch of compute, you might have a bunch of block storage. It's all the same type of storage, all the same resource, but you want to be able to differentiate between them. So this is the name that I'm giving to the resource. It is not the name of my autonomous database, though. That actually is a little bit further down here. And then all of this, again, this is all the information that I need to create an autonomous database. And then these are the values that I'm going to pass to it. And again, I'm just setting variables for these. I'm telling Terraform, there's going to be a variable. I'm going to assign a variable to you, and it's going to come from somewhere else. And that somewhere else is indirectly this variables.tf. So I need to add some variables to my variables file, because remember, I have to have those variables declared first. So these first three variables, all that I'm doing here is declaring the variables. I'm initializing them. I'm not providing any values, nothing like that. I'm just saying I've got three variables: DB name, display name, and admin password, and they're all going to be strings. They're all going to be string variables. And then I'm going to go and I'm going to create a couple of variables here for DB version and DB workload. Now, this is a declaration block, all within the curly braces, and I'm creating this variable called DB version, and it's a string. And same one with this DB workload. This is the variable type, but you notice I've got this default, and so I'm saying this is an OLTP database. That's my default. That's what I want to use for default. So anytime I run this configuration, if I don't provide something different for my DB workload, it'll create this OLTP database type for me. I suppose we have Terraform compute node instance on-prem, and I want to create a DB on my OC compute node. Use Terraform, and we have proper communication between on-prem and OC. Can we directly execute through SSH or any other utility? Are you talking about, Imran, are you talking about being able to run a script on OCI on a compute resource that you've created? Is that what I'm understanding? Because if that's your question, yes, you can run scripts as part of your build process. There's all kinds of really neat things you can do with Terraform, but yes, you can run scripts in your infrastructure as you're provisioning it. Lots of cool stuff that you can do there. So getting back here, I've added these two variables. There are a couple other variables that I need to define here, and I'm going to give them default values because I'm probably always going to create my my autonomous database with these same similar configurations. So I've got my core count and my size, whether or not this is free tier, and my license model. So those are all the variables. I've declared those in my variables.tf file. And now I need to pass those hard-coded values, the things that I want to be able to define specifically for an individual environment or to change on the fly in this terraform.tf-vars file. And so you see here, I've got this, my database name and my display name, and then I've given it an admin password. These are the values that I'm going to use when I run this database. And these are the values, again, that are likely to change every time I run this, because I don't want to, well, maybe you do, but maybe you don't have the same password for every single autonomous database. You may want to have different database names for each of your autonomous databases, just so they don't get confused. So I can go in here, and with each run, I change the values in this terraform.tf-vars file. If for any reason I did want to override any of the default values, I could simply uncomment any one of these lines and provide a value after the equal sign, and Terraform will substitute that value in and override the default that I created. Can Terraform be run via a browser window? Yes, it can. If we have time at the end, I will pull something up and I will show you what that looks like. But yes, you can do that. Oracle has a tool called Resource Manager that lets you do that. So here's where we've added in all of our variables that we're going to use to create. This is our scale. This is our, I want a 3-liter fish tank or a 10-liter fish tank or a 1 million liter fish tank if you would like to give Oracle lots and lots of money for your OCI environment. And then this is that last file that I was mentioning, this outputs.tf. This is where we're going to produce some response, some output that we can read and track what Terraform is doing at different stages. So I'm creating 2 variables here. This first one is called DB name. Now this is a variable name. I'm just making this up. It's an output variable. And I'm going to assign it a value. Now, I brought up down here at the bottom, this is the very beginning of that resource definition that was in the main.tf file that I created a little bit earlier that I showed you. And you see I've got this resource called OCI database, autonomous database, and I named that resource, that object in Terraform, autonomous DB. And so the resource, the value that I'm assigning to this output variable DB name is the resource dot the resource name and then dot the display name. And the display name is one of the properties of my autonomous database. Well, this is also a property that I defined as a variable. I could, if I wanted to, instead of doing this lengthy value equals blah, 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 I could have just said var.displayName because that's my variable name for my database display name. But I want to get that property from my autonomous database itself. So rather than my variable, which I can manipulate and I could potentially change, I want to see what was my display name set to in my autonomous database. So that's one reason that I might do that here. But this next one that you see here, this output DB state, and you see I've got this OCI database autonomous database. So this is a property for my resource. And then I've got this state. Well, this is a property or a characteristic that wasn't in that list, if you recall. And let me just jump over here so that you can see what that looks like. I don't have anything here called state. Now you can probably figure out, I'm sure you're all smart folks and you're like, I bet state is something that comes back from Terraform that reports on the state of the autonomous database. And you would be right. This is something that Terraform is going to report back to us. It's not something that we can set or anything like that within the autonomous database. It's something that the autonomous database reports back, return code basically. So I'm going to capture the state of my autonomous database and assign it to this variable called DB state. And then from here, I can run Terraform plan and Terraform apply again. I don't need to run Terraform init. Terraform init, in fact, if you want to see what that does, is if I do LA, this .terraform and .terraform.lock, these are the files that Terraform init creates. So it's initializing the directory for us and setting that project up. I don't need to run init in this directory ever again. Could you please explain me what are the benefits of using Terraform? Terraform is an infrastructure as code tool that simplifies building infrastructure, and it assures us that we're going to get identical results every time we run. There are a number of benefits beyond that. I discussed some of this at the very beginning, but as we go through this, I'll try and drop in some pointers and say this is another reason you might want to work with Terraform. We're now into preparing DataGuard FarSync instances on Azure Cloud. It should be a copy of our production primary database hosted on-prem. Will be your suggestion on using Terraform to avoid various manual steps. That's interesting. I'm doing something very similar. So Imran, I'll tell you what, why don't you drop me an email if you don't mind, after the session, and we can kind of go back and forth, and I can share some of the the conversation or some of the solutions that I'm working with. It's client work, so I can't give you the code, unfortunately. Maybe hopefully soon, but maybe I can point you in a direction, and we can share experiences, if you will. I don't know. Yes, perfect. Thank you. And I have a slide at the end that has my contact information. So again, we don't need to run Terraform init. We can just go straight into the Terraform plan and Terraform apply. So what does this look like? Terraform plan looks a little bit different than what we saw before. Remember, before there was nothing for it to do because we didn't have anything. Well, now we have some files. We have that main.tf file that's actually creating a resource. And if you look in here, you see that Terraform will perform the following actions. It's going to create this resource, will be created. And then it gives us some information here, and it's a lengthy output. I'll show you this in just a moment. And then down here, we see this plan: 1 to add, 0 to change, 0 to destroy. So it's not actually going to do anything right now. This is the plan. And if I were to actually apply this, this is what it would do. It would add one thing. And then we see this, this line here, changes to outputs. The DB name, this is the database name that I assigned in that tf-vars file, remember? And this DB state, known after apply, because we don't know what the database state is until we've actually created the database. It might work, it might not, who knows? And then the rest of this you didn't use the -out option. You can ignore that for right now. And then we'll go, we've run the plan. It looks like it's going to be successful. Things look like they're going to be good. So now we can run this Terraform apply. And Terraform apply, it's going to come up here and it's going to say, hey, there's going to be some changes to these output values. These are the output of values or output variables that we defined. And when we run Terraform apply, we have to confirm. We have to confirm to Terraform, yes, we want to do this thing. So it's going to say, I'm not going to do anything until you approve it, until you acknowledge that you want us to do this thing. So we just go ahead and we type in yes here, and that will kick off Terraform, and it'll be underway and it'll start doing stuff for us. And so after we enter that value, yes, you see it's going to create the database, and every 10 seconds it's going to come up and it's going to say, still creating. Takes some time to create an autonomous database. But when it's all done, it takes about 1.5 minutes. It'll come up and it'll say, I'm all done. I created or I added a resource. I didn't change or destroy anything. And now I've got these outputs. The database name didn't change, but now you see I have this database state of available. And that available state is just like we suspected. It's the result of the apply that we performed. The database is now up and running, and we have an autonomous database. So let's look at this in practice. This is my cloud environment, my free tier. And you can see here, I've got that little free tier message up here. And if I go in here, I didn't want compute, did I? I want Oracle database. I want my autonomous database. And I'm in my root compartment because that's where I'm going to be creating everything right now. I don't have anything, I don't have any autonomous databases here. Not yet, at least. So now I'm going to go in here and I'll do my Terraform plan. And you'll see this is the exact information that we saw from the slide deck. And now I'll do my Terraform apply. And it asks me to confirm. And now it's going to start creating my autonomous environment for me. While that is going, let me take a look at some questions here. As we already have, let's say console access, Why do we need to use Terraform to create the autonomous database? In simple 3 or 4 clicks, yes, absolutely. You can create an autonomous database in 3 or 4 clicks. Can you create compute, storage, VCN, security lists, egress and ingress rules, compute, run installation scripts, configure that compute, and so on and so forth in 3 or 4 clicks? No, that's 30 or 40 clicks. And with 30 or 40 clicks, now you're getting into territory where I might write down the instructions for what you click on and what you enter in all of those different fields, but maybe somebody reads those instructions and doesn't understand them. And now the environment that I built isn't the environment that somebody else built. And when those two things aren't behaving the same way, well, how do you know where it's not behaving? You know, what's different between them? Well, with Terraform, I have this, and it does it all for me. It's all scripted. It runs automated or automatically in the background for me. I can kick off my build, and I can go and eat my lunch and come back, and when I'm done, I have everything built for me. I know how it was built. It's nice and reliable. So that's the advantage. Yes, for building an autonomous database, you can do it pretty simply, but I didn't want to show you a really complicated Terraform configuration with lots of different things that might be distracting. And I'll talk about some of that in just a few minutes. So I wanted to keep it simple, and creating an autonomous database is a nice, simple exercise, I think. Looking for similar kind of POC for DR build, please share. Okay, email. I believe it's for multiple database requirement or sometimes customization purpose. Yes, so yeah, that I think that you're responding, Imran, to why we would do that. So you just answered the question that I did. Mass deployments avoid human errors. Yes, thank you. Avoid human errors. That is a top reason that we use automation. Can please someone here? Let me. I'll pull up that. There we go. So this is the. Oh, sorry, that's not the right one. So this is the address here, this Oracle Sean /Terraform for Oracle DBAs. I'll just copy that into the chat for you here. So that's the link to the project for you there. But let's jump back to our project here. So you can see that it went through this process while I was talking. And oh, this took 2.5 minutes. Oh, this is a free tier. It was a different example that I ran that on. But you see down here, I have my outputs, and I have a database state that is available. So let's go back and take a look at my OCI. Here, lo and behold, I have my autonomous database that was created for me. This was built for me by Terraform. So I didn't have to do anything, just created, available, nice, quick, easy, everything I need right here. So let me show you one last thing that you can do with Terraform. Let's say that I don't want this autonomous database anymore. I'm all done with it. I can do Terraform destroy. And this is going to be just like apply. It's going to say, are you sure you want to do this? Because I can't undo it. And again, I have to respond in the affirmative. I have to tell it yes. And it's going to say, 1 to destroy here. Do you really want to destroy all of your resources? I tell it yes. And it'll go through the process of destroying my infrastructure for me. The really nice thing about this, when you're working with Terraform in OCI or Amazon, whatever cloud provider you're working with, and I'm guilty of this, I'll go in and I'll create stuff manually. I do lots of manual stuff in the cloud. I try to do as much as I can with Terraform or Docker, Vagrant, whatever automation tool is most appropriate. But sometimes you create a bunch of resources and there's a specific order that you need to delete things in as you clean up the stuff that you created manually. Well, Terraform knows what that order is. Sometimes I forget, and there are times where I will go in and I will delete things out of order, and then it just becomes a huge, oh, I can't believe that I did that. Now I can't undo this. I can't remove this other thing without jumping through all kinds of hoops. So Terraform is really good about keeping things in sync and doing everything in order for you. You don't have to tell it the order. So you can see here that I started running that destroy, and my autonomous database is now terminating. So it understands that Terraform is destroying that database. We'll let that run, and we'll jump back here. So this is my Terraform apply. So again, I mentioned earlier that we can go through the process of putting everything into a single file if we wanted to. I personally like having separate files because as you start building more complex Terraform infrastructure, you'll run into cases where you're building compute and you're allocating storage and you're building networking and security lists and so forth. And sometimes it's nice to have all of those operations contained in individual files. And because we don't have to worry about the order of operations, I can create compute and put all of my compute resources into a single file. I can create all of my storage and put that all into my storage file. And so it keeps things organized, and I need things to be organized for just to be able to keep track of them. So we have this more portable or more reusable code. So I like, as I said, having things that compute VCN storage variables. As long as it ends .tf, Terraform will read it and understand that it's a Terraform file. It's referred by old DBAs to do manual removal, as we know how we face worse situations. Yeah, sometimes manual it's certainly faster to do something manually than it is to write automation to do something manually. But there are a couple of folks that I know from Oracle and colleagues on Twitter. We often joke that I just spent 3 hours writing automation to do something that would have taken me 10 minutes. But those 3 hours are recouped because, well, one, now I understand the automation a lot better, but now I can run that 10-minute process over and over and over again without having to go through the manual steps, and I can get a cup of coffee if I want while that's working. Have you taken any Docker sessions earlier? So could you please provide links? Yeah, absolutely. Send me an email. I'll have my email at the end of the presentation, and it's in my GitHub, and it'll be in the slide deck as well. But yeah, I have some Docker presentations on my YouTube channel, and there should be some recorded sessions from some other conferences. I'll dig those up for you. So again, this is the reason that I personally like to have everything separated out into individual files. If you found this presentation interesting and you'd like to learn some more, I do have a Terraform for Oracle DBAs online class coming up. It's 3 2-hour-long sessions. It's going to be September 1st, September 8th, and September 15th through Orapub. And we do this first part of the Autonomous Database Lab. That's part of the very first session. But then we go a little bit deeper and dig into creating VCN and compute resources, creating storage, block storage, and mounting that block storage to a compute instance, setting up all of the security rules and ingress and egress and so forth. And then also pulling assets from object storage, specifically database installation files, and making them available so that you can run the installation scripts. So these are the scripts that I was mentioning earlier. You can run those installation scripts. Run the configuration and installation scripts, and then build some interfaces with Resource Manager. And that was the other thing that I was going to show you if I had time here. And this define and deploy configurations from a web page. Which is pretty cool. So if you're interested, that's the link. This is through AuraPub. I don't know if you're familiar with Craig Schellahammer, but Craig has been doing AuraPub for many years now. So here is all of my contact information. I'll leave this up here for just a moment, and it looks like we have some time here. So if anyone has any questions, all the major cloud providers, mostly DevOps deployed. Yeah, Ansible, Terraform, Jenkins, containers, easy and error-free. Yeah, it's automation is really wonderful. It is a true lifesaver for a lot of things because it lets you set up very reliably identical environments, and we don't have quite as much worry about, is my test environment, is my development environment going to behave like my production environment? Well, you know it is, because they're identical. They were built identically. Again, the scale may be a little bit different. It may be a bigger environment and a faster environment, but functionally, they're going to operate the same way. So that's one of the advantages of that. So let me take a look here. Let me pull something up, and let me find the right lab here. So if you don't mind bearing with me for just a moment, I can show you. Someone had asked a little bit earlier about if you can run this through a web interface. And I'm not going to be able to actually run this on, yes, here, okay. I'm not going to actually be able to run this on this free tier instance because it takes a little bit more horsepower than free tier. Actually, you can run it on free tier, but I'm not really sure why about that blue line there. But so this is another repository in my GitHub here. This is this upgrade lab. And you see here, I have this button, deployed Oracle Cloud. So this is a Terraform project. And here I have this file called schema.yaml. And I know this is probably, especially if you don't work with YAML a lot, YAML standing for yet another markup language. And this probably looks really, really intimidating and confusing. But all that this is doing is some scripting, some declarations that let me do what I'm about to show you. So I've got this deployed Oracle Cloud button here. And because I'm signed into my OCI environment, oh, maybe I'm not. Let me just log in here. Okay, so I clicked on that deployed Oracle Cloud and I logged into my cloud account, and look at this cool thing that I've got here. So yeah, I've reviewed my terms of service. This is what that YAML that I just showed you does. And this is part of what I teach in the class that I was just mentioning, the AuraPub class. So I can create this checkbox, and as soon as I click that, it's like, look, I'm going to give you some information about this. And then I can go through here and oh, this may not be the one that I think it is. Oh, yeah. Oh, maybe it is. Okay. Yeah, so this isn't actually going to work, but I can walk you through so you can see some of the web interface. So this is going to go and it's going to create some Docker containers for me that let me test upgrades from 11G or 12C to 21C. And so I can go in here and I can say, I want my starting version of my database to be 11 or 12. We'll just go with 11. And then I can click on these advanced options. I can auto-generate a public key and so forth. And why is it not giving me? I don't think this is the lab that I thought it was. I have several labs. I apologize. It should have given me. Oh, I know. So I have one of these labs. The one that I pulled up isn't the one that I thought it was, but I have one of these labs that goes through and it lets you put in. You can not just through these drop-down boxes, but you can type in values and you can supply passwords and you can do all kinds of really interesting things to set up and declare how you want your Terraform environment to run. And then when you click this next, this run apply, if this looks familiar to you, this is us checking or saying yes to Terraform apply. I'm just going to leave that unchecked for right now. But now it's going to go through and it creates this resource manager job for us or stack. And if you've gone through and done any of the Oracle Live Labs, then this may look familiar to you. If you've gone through, maybe if you attended Pi Day or any of the other special events that Oracle has done where they had you provision some infrastructure for machine learning or AI-based things, anything like that, then you may have seen something that looked really similar to this. And this is a GUI version or a web-based version of Terraform. It's just a front end. All that this is doing is putting a nice, fancy, pretty looking interface or front end on this. So instead of seeing this, you get something that looks a little bit nicer, I guess. So again, you can see here are my variables that I'm signing, and this won't run in this environment because it's not powerful enough. Oh, I don't know, maybe it will. But you can see here, well, at the very least, I'll let you see the logs. I can always destroy it later, can't I? We'll give it a second. Any moment now, those logs will come up. So this is just a front end on top of Terraform that gives you this graphical front end that makes it a little bit more accessible. And so if you have some folks, an example of why you might want to use this is you may have development teams in your environment that need to create databases, but you don't want to have to create the databases for them. You want to be able to give them that ability, but not have to teach them how to create a database, which is a pretty deep subject in its own right. So you can give them a resource manager job like this, and they can go in and they can deploy it, and they can say, this is what I want the database name to be, and this is how big I want it to be. And now you've given them the power and the capability to do that on their own. And they're free to do that. They don't have to come over and ask you for permission. They don't have to ask you to do it for them. And now you can do other things that are maybe, I don't want to say more important, because what your development team needs is important. But if you can give them the power, it means that you can be doing something else. So you give this ability, this automation to your developers or to teams in your enterprise. It lets them go and do things on their own without having to know how to create a database. So this is that same log that we saw from Terraform apply. Like I said, this was going to fail, so big red box there. But notice here, this all looks really similar to this. And it's because it's the same set of logs. It's the same type of output that's being generated through Terraform. And it's just being sent to this front end for you. And of course it failed because yeah, I don't have enough resources to run this on my free tier. But that gives you an idea. You can see what it looks like to do that. And now I can go back here to my stack, and this is Terraform destroy. It's the same Terraform destroy command that I was running before. So I can manage this all through my OCI console if I want to. So with that, this is my contact information. Let me, I just want to copy the chat out here in case it's lost. And then I can respond to everyone's emails and make sure I get information to the folks that I promised information to. Does anyone have any questions before we close out for the, I was going to say for the evening, but for the morning for you?
Yeah.
All right, I got all that copied out. Any questions? If not, I will turn it back over. Thank you, everyone, for attending. Oh, I got a yes. Sunil says he has a question. While we're waiting, thank you, everyone, for attending. I appreciate you being here and appreciate your attention. Thank you for having me and letting me rant and rave about Terraform and how wonderful it is. I hope you have a great Saturday, everyone.
I think Sunil have some questions. Just trying to unmute him. Okay. Yeah, if you have any question.
Can you hear me now?
Yeah, Sunil, go ahead.
Okay. Actually, I was when I started my career, it was as a.
No, your voice is too low.
Is it better now?
Yes,
oh, much
yes.
better. Yes.
Okay. When I started my career, it was like a Oracle DBA. Then I graduated to Oracle Apps DBA. And last 8 years, I thought that it is better to stay out of touch with Oracle because a lot of open source non-SQL databases were coming up.
Mm-hmm.
And I explored on those areas. Now I want to come back into the Oracle domain. So what do you suggest me to get back into this domain? I have around 20 years of experience, around 15 of this in Oracle technologies, and rest 5 in React and all these kind of things. So what do you think I should do now?
You know, there is a lot of really great information and some wonderful resources that Oracle puts out through their live labs. And I believe it is livelabs.oracle.com. And those live labs are going to be free guided lessons on most Oracle technologies. I know that there are live labs out there for just for a whole variety of different things. So what I would suggest if I were trying to get back into Oracle after being away for a while would be to go in and maybe like look at some of the 19C new features and some of the 19C database things. I would say that performance tuning is probably an area that I would want to brush up on just to see, you know, how things are different in the 19C version. And I would really look at 19C as the database version to brush up on. And then maybe look at DataGuard, upgrades and migrations. So things on auto upgrade, things on migrating databases and the DataGuard setup, because those seem to be the areas where I see most of the activity and demand. But that the live labs really, that can't be beat because it's free. And there's so much information out there, and they are really nice guided labs. So you can be, it's not like reading a book or watching a video, which some people can learn that way. I personally, I need to actually do it hands-on. So I think that those are wonderful resources for you. That's where I would head. And then I had a question here. Can I create these OCI resources in another compartment as well, or will only work under root? Absolutely, you can create them under another compartment. And I apologize, I did not cover that. I did not mention that here. But here I've got this. Let me just do this main.tf. So in this file here, I created this resource and I said I want it in a compartment ID, and I gave it my tenancy ID. I could, if I wanted to, here in this, this is my example file here. I could set my compartment OCID, this value, this variable, to the OCID of whatever compartment I wanted to create. And you can even create compartments and subcompartments as part of your Terraform build, if you'd like, and capture the output value from the build of the compartment. Just like we use the state of the autonomous database, we can return that into a variable and use it in other things. So you can create a compartment, and then without knowing what the OCID of the compartment is going to be, use that compartment to build your autonomous database if you wanted. So then instead of using my tenancy OCID here, I would use the compartment OCID of whatever I wanted. So yes, you can absolutely create them in different compartments. Doesn't have to be the root. But great question. Thank you very much for raising that. I apologize for overlooking that whole thing. Any other questions?
I don't see any more questions in the chat.
All right,
Okay.
great.
Yeah.
Well, thank you again. And again, I'll put up my contact information if anyone didn't get that. And feel free, like I said, to reach out. I'll upload the slide deck to the GitHub repo in just a few minutes. All right.
Yeah. Thank you, Shane. Yeah.
All right.
Thank you for your time.
Appreciate it.
Thank you all.